Hi, my name is Kristaps Bebris, and I'm a lead developer. At, and I'm a lead developer at Emergent. And I'll start with a statement. Most of us have probably tried to create a machine, or at least thought about creating a machine learning model at some point. And all of us have figured that we could help our company, help ourselves solve a problem of some sorts by leveraging machine learning. But as you start approaching the subject, you realize that it starts looking like an ever bigger and bigger mountain of different challenges, of a lot of math and a lot of complicated issues, essentially. But today, I want to tell you that it doesn't really have to be. The tooling's become so good at this point that you can reasonably make you can make a lot using very little, and you can start prototyping really quickly and get off the ground running. And I'm not going to talk about it in a theoretical sense. I'll show you a project that I've been working on for a little bit now, and that I'm still working on. And it's a project that we've got that we're running internally within Emergent. So just to establish sort of an overall picture. So Emergent's a company that works with other companies to help them work better, to improve the way they work. And we've got three sort of main ways we work in. So there's engineering, there's consulting, and there's learning, which is the one that's going to be relevant for us today. As far as the company in Latvia is concerned, we've got around 350 people here working in 4 offices, and there are more than 700 people working at Emergent globally. And we work with a lot of big brands that you've probably heard about, like SAP, Walmart, The Economist. I think there's BBC as well. And this is the overarching message, and this is the overarching message that the presentation is running under as well. Where I want to show you that you can make something really easily. I want to show you that you can make something today, tomorrow, the day after, and start delivering value to you, to your customers. And yeah. So, as I said, our object is going to be learning in this case. So we at Emergent have a learning platform. So you go through some courses, you're taught a bunch of theoretical things that you could apply to the way you work. And then you have the chance to take a self-assessment quiz to figure out if you've actually got anything of the things that were taught. And the thing on the page that you saw before, when you've got multiple choice questions, this is simple. The site gives you instant feedback, and you instantly know if you've understood the course material. But then we reach the second one. And that's a somewhat open-ended question, and it asks for an answer in free text. And you can't preemptively map it. So you can't say what the exact correct answer is. So up until this point, people would come to the WordPress site, which is the learning platform. They'd go to the quiz module, fill things out, everything would get stored in a big database, then it would be get dumped into Excel files, and somebody would grade the questions once in a while. So you completed your quiz, you don't know if you're correct or not, you wait a week, you wait 2, maybe 3 weeks, and then you've forgotten about the quiz and you never find out if you actually got the material. And that's not fun. And it's a job that's not really fun to do on the other side as well, because you get thousands and thousands of questions to grade, and it gets really old really quickly. So we started thinking about what could we do. So this sounds a lot like a cognitive skill, and people have been people have been advancing the possibilities when it comes to automating cognitive skills really rapidly in the last 4 years, just about, where we're getting self-driving cars that look like they could actually work. We're evaluating people who are applying for loans automatically and rejecting ones that look weird, don't look like what we're looking for, your phone does photo tagging essentially in real time, where you mark faces and it's going to find similar pictures if need be. But, okay, fine. So we want automated cognitive skill. So how do we go about this? Since we're a machine learning team and machine learning is really fun to deal with and it's really hot at the moment, we figured, let's go this. We don't try to make an expert system, we go machine learning. And that becomes an approach of you tossing data into a big pile of linear algebra, as XKCD's webcomic says, and you stir everything about and hope for the best. And if it doesn't work out, you need more computational power. You need to stir the pot even more, or maybe you need to look at something else. But there is a problem in that training a complicated model on a large amount of data is very, very computationally expensive. It can take dedicated hardware. It can take a lot of time if you don't have that hardware. And you need massive amounts of data for the quality models. But there's a second part to this. Once somebody's trained the model, if you know how to use it, you can reuse it really easily. And it essentially evaluates in real time. So we may want to look at something that somebody already has created for us. And then there's the question of when do you look at machine learning? Because it has become a bit of a catch-all. You see a problem and you go, okay, machine learning. It's so popular, everything's machine learning, this, machine learning, that, and people start wanting machine learning just for the sake of having machine learning. But there is a time and place when you actually want to apply it. So if something feels like it's going to take a massive amount of work to scale, and if it feels like it's a cognitive skill that's based on a snap judgment, then you can probably automate it. And in all likelihood, you don't need massively complicated models to automate a lot of it. There are going to be cases that aren't feasibly doable, but in a lot of cases, this holds true. And the second comes from an HBR article that was published a couple of years ago. I've heard about it being pushed up to 3-ish seconds, maybe 5-ish now. But since I couldn't find the source, then I'm sticking with the second for now. So, okay, we figured out we're going to approach our problem like this. So I went to the learning guys. I said, I'm going to help you. I'm going to make a model. We're going to try grading this on the fly. And they gave me a bunch of Excel files. And they gave me around 1,000 answers. Some of them were marked, some weren't. And the initial data set ended up being around 500 answers. And as you'd think, I looked at it and I thought, okay, maybe I can do something with this. But since I can't properly classify the answers myself, I have to rely on what they're saying, because there were multiple cases when I'd look at two answers, one's correct, the other's incorrect, and I can't tell why. Both of them look weird to me. So, okay, fine. So we're working with text. But as we looked at it before, we need to be able to deal with this in a linear algebra sense. And you can't really do math with words. It doesn't quite work. You can always try, but words, numbers, not really the same thing. So we need to convert the answers we're getting into something that we can use in a mathematical sense. And luckily for us, ever since 2012, there's been a thing called word embeddings. And there's a multitude of them. Some made by Google, some made by Stanford University, some made by Facebook, and some made by other companies. But the key point is that it's a system for converting a word into a numerical representation of its meaning. So you get a multidimensional space, and each dimension explains some sort of not really human understandable aspect of what this word means in relation to every other word that the space has seen before. And the bit that we're really interested in is that they're freely available. They've been pre-trained, they've been built, they contain a lot of words, and you can just use them. But you have to have the tooling to use them, because loading the binary files that, say, Google produced and trying to come up with all of the decoding yourself is probably going to be a bit of a pain. So we take a look around and we see Python. And Python's really handy when you're looking to prototype something. So in our case, we want to deal with words, so Jensen's our thing. It allows us to load everything really quickly and to just use it. We want to make it available to the people in learning so that they can test the model out. So we want some sort of web wrapper. We go with Flask because that's pretty much the simplest thing I could find. And then there's scikit-learn for all of the statistics, for all of the machine learning that has to come on top of it. And so just to put my money where my mouth is, you can initially end up with something like this. And the contents of the code isn't really relevant. The point is that you've got around 35 lines of code, and it does everything I just said. So it's completely self-contained. You can load the embedding space into memory, you can train a model, you can accept a result, and you can classify it and return it as an API call. But if we use something really, really simple like this, it's quite good to get people excited and to show them an initial result, but it may not be the most clever thing. And in our case, as we found out, it could hit maybe 65, 75%, 70% precision, but other than that, it would make mistakes at really weird spots. Sentences that are obviously correct or incorrect would get misclassified, everything would have a really low confidence, and it was okay as a concept, but it was nowhere near a practical. It was nowhere near to being practically applicable. So we started thinking. And what can you do once you've realized that your model isn't performing that great? Well, the first thing is you have to look at your data. Because it can just be the case that your data is faulty. And since models take everything absolutely literally, if the data is faulty, you just end up learning patterns that represent the faults in the data, and nothing more. And it may look like a valid result in some cases, but it may become completely invalid in others. And then there's the thing of how we handle text. Because having a translation layer and the embedding space from words to numbers that we can now use to operate with our models is all great, good and all great. But we're just taking the average at the moment. And a sentence isn't really an average of each word in the sentence. Because a sentence that contains 5 ands and a couple of words in between isn't more similar to the ands than to the actual things that the sentence has been about. But in our solution at the moment, that's the case. It'll just take the average. And then there's the question of trying to figure out which model you want to use. There's a fair number of them. That's why we're using scikit-learn, because there's decision trees, support vector machines, random forests, and a bunch of them available that you can just plug in and use. And so we figured that since our data set's looking weird and we can't tell why the answers are correct or incorrect, it may be the case of the grader being grumpy in some cases, or maybe being really forgiving in others. And since people really didn't want to grade in Excel anymore, since I'd already told them that we could try to automate it and everybody was a bit hyped, we figured that a grading interface could do the trick, and it actually worked surprisingly well. You create a simple feedback loop. So I'm gonna show it to you in action now. You create a simple feedback loop, whereas you ask a person to enter an answer. It replies with what the current model is thinking the answer should be classified as. And then you tell it, do you agree with it or don't you agree with it? So say in our discovery mindset, oh, you can't see the screen. You don't see the VM. Damn it. Okay. Right, so I'm just going to talk you through it. So Oh, 1 second, small technical issue. If I kill it and if I refocus the screen, you can't see it. Great. Okay, so you make a simple interface. Your expert who's helping you improve your data set can select what answer are we working with, and then you enter like what is the discovery mindset. I don't know, maybe one that's really involved. Nope, apparently that's not the case. And now we think about it, and yeah, it's probably not the proper answer. So you tell the model that, fine, you agree with this, it gets stored off, and you go to the next question. And this, in a practical sense, worked a lot better than just having people fill out Excels. Because there's immediate feedback, plus you, as the model gets retrained in between the data set being improved, you get the instant sense of there being progress. So you're not just sitting there creating giant data files, you actually see that your work has a result as well. But as our data set's improving, we need to address other issues that we're having as well. One of which is we're not cleaning the data in any way at all. And it turns out people don't really care about grammar that much. Especially when you're taking a self-assessment quiz. You just want to type your answer in, click submit, go next. Type it in, click submit, go next. And you can get a lot of weird interpunction, you can get weird capitalization, you can get sentences that have way too many spaces, you can get words that have essentially fused together. And initially, those two sentences would be completely different for our model. The first one would just be a single word that's in no embedding space, so it means nothing. But if we use the same library we use to load our embedding space, Gensum in this case, the tooling exists. It's just a question of you using it and calling it. And you can get sentences that have been reprocessed, they've been handled, and you end up with data that you can work with further. In a similar fashion, when it comes to actually dealing with the way that we look at a sentence, which at the moment, as we're just taking the average of each word, isn't ideal. There are some comparatively simple methods that have been around for a little while, so they're actually proven, that give you simple ways in which you can create something that's practically applicable. It's not going to be F1's course, it's not going to be state of the art. Like it won't be the best thing in the world at the moment, but it'll work in practice, which is the thing that we're looking for here. Because we're not fighting against benchmarks, we're trying to classify answers in a binary sense. So we don't actually need anything that complex. And just as they promised, it's again very little code. Since you have all of the tooling, since the library support at this point is so good, you can end up with a prototype that essentially exists after a couple of days of work. And you can try it, and you can keep rolling it out, and you can keep improving it. And since there's the instant feedback loop, you can get the people who are providing the data for you really involved and really interested because they see the progress. It's not you going away for 6 months and then turning back up, and they get whatever. But there's also the question of how do you figure out what kind of model do you want? And I've found that the best way to think about this is what's the shape of your data? Because different models are going to approach your data in different ways. So say when you're looking at something like decision trees or random forests, you can see that the model is splitting everything in straight lines. So it's assuming that every feature that you gave it, every dimension that exists, is good enough to be used in a decision. So it just uses them directly. Or maybe you need something more complex. If you need combinations of your dimensions, of your features, you could use something like, where is it? You can use something like support vector machines. Oh, there it is. which uses functions of a high power and wraps around everything and creates rules that are essentially combinations of your features. And so we started working. As we initially hit off, everything teetered around 60%. So, okay, it was enough for people to get interested in what we were doing, but not really enough for anything to be used. And we started experimenting with models, and the precision kept going up ever so slightly. And in this case, we found that random forests work really well, because the embedding each dimension of an embedding space is already a combination of different features. So the fact that a random forest splits everything into straight lines isn't an issue here. But in your cases, as you approach problems, this may not be the case. You may find that you actually need the combinations. You may find that different models work better. But as we progressed, we started messing with pre-processing approaches. We started messing around with using different embedding spaces, not only the Google one, but the Stanford ones and the Facebook ones as well. And the drop here is a lesson learned for me, because I thought I was going to be clever. And I was going to save space by running one of the pre-processing steps before I saved the data. So I decided I was going to purge everything of words that don't exist in the Google embedding space, which means you ended up with sentences that had chunks missing from them. And as you try changing embedding spaces, you end up with essentially nothing left of the sentence because you didn't store the ones that are missing from one and maybe present in the other. So that's an interesting thing I learned. But luckily for us, the Google space turned out to be the best one based on the other models, so I ended up sticking with that one and just updating the rest of the code so that this issue doesn't become a problem in the future. And towards the end, we reached a baseline performance of around 75-ish%. And we started looking at the performance more closely and realized that, okay, on baseline, the model is not that great in some questions, but if you start looking and trying to figure out when is it confident, start adding a threshold to the confidence, and you let the model make a decision that gets fed back to your user when it's confident enough, the precision is actually quite good. Okay, it makes a mistake once in every 10 people or so, but getting instant feedback in our case in such a low stakes environment where it's a self-assessment quiz, or maybe it's a chatbot or something like that, 1 in 10 it's not great, but it's not that bad. It's something you can actually try out on people at this point. And so we did. And afterwards, we realized there's a problem. We're not taking all words as equal anymore. But since we're using essentially a method that doesn't understand word orders, from its perspective, all of these sentences are exactly the same. And so this is where we're at the moment. It's something that I'm really aware of. It's something that I really like to fix, but I haven't picked a solution that would work for this really great. There are some available, most are neural network based, but there's the question of, is our dataset sufficient at this point? Because we've grown to around 3,000 examples in total, and it's enough for a simple statistical model that's working on top of an embedding space to work, but it may not be enough for something a lot more complex. So we won't know till we try. But there is still a point to be made, and that you shouldn't forget that you're not doing machine learning just for the sake of doing machine learning. We've still got our business problem that we're trying to solve. So in our case, we're trying to automate the question grades. So we have to remember that we still have to give feedback. We have to keep track of the data. We have to keep track of what we're doing so that we don't get lost and start doing everything just for the sake of doing things and because it's fun and it's math. But we still want to help people. We still want to produce a result that's... And as we started thinking about how we'd be able to do this, we realized that there is a bit of a problem in that the learning platform exists at the moment in its current state. So it's a big monolithic structure. And since we're actively experimenting with our models, asking the guys that are keeping the learning platform up and running to redeploy it once every couple of days when we decide to try a different model out would probably not be great. They get really, really angry at us really fast. And plus, there's a lot more people involved, so it's unnecessary overhead. And we started thinking about it, and we figured microservices, great. We created a complete, loosely coupled service that we can manipulate ourselves, that can be deployed on its own, and it's completely independent from the rest of the learning platform. And we ended up with something like this. So we've got microservices that the learning platform can call. It can grade the answers, and it can return results. So on a more individual basis, currently, I've kept the servers as lean as possible. So the approach has been essentially the same as to the coding, as to the development of the models. Whereas you want to deliver quickly, you want to deliver often, and you want to create as little overhead to yourself as you can. So you've just got Python running, code getting sifted through Git, and then there's Unicorn and Hot Proxy handling the web traffic in our case. And if you're just calling the API, you just get a JSON response. If you're using the training interface, there's Jinja and there's JavaScript on the front end helping you out with that. And of course, just as the model, this can be improved, and this has to be improved as well, because there is going to be a point when a couple of servers that I can manually update and restart are going to become a problem scalability-wise. And so we can add Redis to help share the embedding space in between instead of loading it in between the workers instead of loading it for each of them individually. We could use PyTest to figure out if we haven't broken anything. And unit testing, in case of machine learning, is actually a really interesting thing to touch upon, because you can get a solution that technically works but makes no sense. As we had before, our initial attempt technically worked, but the results were completely bonkers. So you have to think about the fact that when you're validating your outputs, you not only have to validate the fact that you got an output, you have to validate the fact that you got the one that you'd expect. Or maybe the dataset's gone wonky and everything's gone across the walls, essentially, and nothing works anymore. And so now, once we open the site, we can, screen. Now we've reached valueflowquality.com, which is the learning platform that I've been going on about. And here we've reached the free text answer, and maybe somebody wants to give me an answer. Yes? No? Okay. So we can add something like mindset of So is it going to like the word mindset? Let's see. Nope. And the learning platform could probably be improved to give you more feedback, but just as the one beforehand, at the top has been marked that it's incorrect. And you've got your question instantly graded by a bot. You didn't have to wait for a week. You didn't have to wait for 2. You didn't have to wait for 3. You've got your result here. There's still going to be edge cases. It's still not going to work perfectly, but it works well enough for such a low stakes. It works well enough for such a low stakes environment, such as a self-assessment quiz. And all in all, the points that I want to make is that you shouldn't be afraid to reuse models. That's one of the key ways that you can actually leverage machine learning now to make something really, really fast and make something that's going to be quite good in practice. Because most of the pre-trained models that are out there have been vetted really carefully. They've been around for a little bit of time. and people have checked if they're actually usable. So you can think of them as components, as libraries, as things you can just use in everyday development, essentially. The same thing applies to the complexity. An initial demo doesn't have to be complex at all. An initial demo just has to be complex enough to capture people's imaginations. If you show that in principle you can convert text into some sort of math and there's a black box behind it and you can get a result back to them, people still care that it makes mistakes occasionally, but if it's right enough in enough cases, it becomes a case of, oh, how can we improve it? How can we make it better? We want to help you. We want to get these results. We want to get this automation out there. And you have to keep it decoupled enough from everything else to actually be able to deliver this value constantly. So people have been working really hard. You've got another 1,000 classified answers. You have pictures that have been classified, and you want to get it out into your site. And if it's going to be part of the site, it may not be possible to roll it out as quickly as you want. There may be issues with restarting the whole thing as often. People may not want to do it, but if you're loosely coupled with it, you can just do it. The site doesn't care. It's still getting a class. You're still telling it whether or not it was correct or not. You're just better now. And the last point is that you don't have to be afraid to actually explore the space. There are a lot of resources since the machine learning as a topic is so hot at the moment. Everybody's making tutorials. There are libraries being built. There's multiple choices for most libraries even, and you won't know if your result works until you try, because something really simple can start producing results that you're actually proud of, and that help you work, that help somebody around you work, and that, yeah, and the whole process can be a lot of fun, both for you and everybody else, as you see as your creation grows and grows and grows and improves ever so slightly. And I suppose is the main point I want to leave you with. So stay curious. Thank you. Any questions?
Well, I have one question. Are there people developing machine learning robots that are designed to fool another machine learning robots?
They actually sort of are. There's been a lot of research recently into this, which is kind of funny, because probably a lot of you have seen the pictures with people with those funky sort of twirly glasses on their eyes, which are designed to fool facial detection algorithms. And making sort of examples like that is all fun and good, fun and games. And then somebody realized that you can actually train things like that. You can tell it that you can make one model want to break the other one and make them fight. And over a long period of time, they improve one another in that way. So you use a previous version to fight the new one, and then then again, and they swap constantly. And that's actually how Google managed to train AlphaGo to beat all those people. Because nobody who trained it could play Go that well. The model played itself and racked up thousands and thousands and thousands of hours of experience. And we ended up with a model that could beat people at a game that was considered unbeatable, I think, 2 years ago. Like, it was still considered that it probably wouldn't be possible.
Thank you.
How do you think by yourself, your approach can you reach the goal that you can correctly evaluate those answers which are pre-faced? Because I didn't saw that you mentioned that are taken in account some dialectics or some sort of object relations.
Nope, nothing's taken into account at the moment. That's something you can improve. That was one of the points that I wanted to make, and that it's not perfect, and it's probably never going to be perfect. But given the environment where we're operating in this case, and given the goal of just being able to provide an answer in real time, it doesn't have to be perfect. It has to be good enough. And that's the case in a lot of cases because self-driving car algos aren't perfect as well. They make mistakes. They just have to be good enough not to crash into things constantly. And since this is a problem with a pretty well-defined domain, and say a chatbot could be a problem with a pretty well-defined domain as well.
So you are accepting that there could be situations that evolution probably, in general cases, will be correct, but in the same time it could be false positive.
Yes. And I want to make a point of that not being catastrophic. It's not perfect, but you still have a system that works. And you still have a system that involves a lot less manual labor as a result. Oh.
Say, have you thought about excluding those people who make mistakes at the input? If they can't type it right, there are red lines under it, and you just don't use it. Or you could just collect the clean data set with those who can write properly, and they receive the service.
In our case, that's a bit of a funky problem because you'd actually be surprised at how many people make mistakes, and we'd end up with pretty much no data. So, and maybe an argument like that could be made that you could use some people who write in proper English, which would mean that you could use rule sets to define the structure of the sentence and traverse it to figure out what the meaning is. But that's not really an option if we are operating with a total of 3,000 data points and excluding, I'd guess 60% would hurt us pretty bad. It's still something you can explore though.
Did you consider opportunity to use the semantic technologies, like technologies, for example, to say content for extracts and so on? Use different phrases in different places.
Yep, that's what we're thinking about this week. It's either using ontologies or a thought was you can train those embedding spaces to adjust the meanings of the words. And the thought was that we could probably get our learning materials, dump all of them into a training algo and hope that the vocabulary adjusts accordingly. Because, yeah.
I was working on this problem over 10 years.
Oh.
You can build automatically ontologies based on
Yeah. But that introduces a lot more complexity, though.
yes, but you should move in that direction because machine learning is quite good at simple collection of data and so on.
Yep.
Because if you consider language opportunity of language model in this space, that work will be so local, and
Yep.
you cannot gather meaning.
Yep. And you can over time you can continuously keep improving it. Yeah. But the idea here was that I created the initial demo in a week, I think. And you can't create a proper ontology system that quickly. Yeah, and for results that you can create, you say, since you have the library support, like I'm assuming it's 3 hours, 4 hours of work till you figure out which function you want to use and get 40 lines of code up and running. And at that point, you can show it to someone, and then you can see how bad how bad your result is, and try to figure out if you have to toss the whole thing, or if you just have to start popping components out and replacing things. So as far as simple demo, not demos, as far as simple implementation, simple piece of software goes, it's I'll be repeating myself, but it's not perfect, but you can make it quickly, and it actually does a job, or not a perfect one, but a good job.
Thank you.
Regarding your example with word only, can you try sequential model like SKM?
Not yet. That's why the word only is there, because I'm aware of it. And I was thinking of trying it out a couple of weeks ago. I didn't have the time, and then I went on vacation. So it's in the pipeline at the moment. But what do you think, LSTM wise? Because our data set is small, and there's a lot of grammatical issues. So until we try, I'm not sure if it'll be able to pick up the word orderings properly. Because you can get properly odd answers when you let the model out into the wild.
Maybe you don't need to solve those grammatical issues. You need to ask again. For example,
Maybe that's a good point.
if you have wrong motion, for example, you can ask user again another word, for example, and explain that your provided answer
Hmm?
not good enough.
Yep. But that's a thing where the learning platform has to catch up with us now. Because this was integrated, and they're just triggering an endpoint. And now they'd have to figure out how to update the user experience, how to update the user interface to properly facilitate the fact that that answer is no longer being left unanswered, ungraded, and it's always getting a grade instantly. So it's places to grow. There's the possibility of progress in essentially any direction still. Anyone else? Okay.